All right, so let's take a look. Okay, here's just a couple of visuals. I think you're kind of familiar with it anyway, but remember that if we're going to put the g of x into the f of x, our input is that x value. In this case, we don't know what it is, right? But we can certainly find it, or they give it to us. And we input that into the g, all right? And we take that whole g of x, and then that g of x becomes the input of the f, and that output then becomes that f of g of x, or this, in other words, is the what? The composite. Okay, so this is just kind of a visual of what happens as we do the composite. Okay, so we're going to do the g of f. So we'll start with the g. So that is 4. And then in place of the x, we're going to put the f of x in. So that's our 2x squared minus x plus 4. And then plus your 1. Be real careful when you do composites that you carry through with all of the information in your formulas. So what would we do here? We would distribute. So that would give us 8x squared minus 4x plus 16 plus 1. Can we do anything to that? Yes, we need to combine those like terms. 8x squared minus 4x, which would give us plus 17. So I want to go back to originally what we started with to talk about the domain. Okay, let's start with the g of x. G of x is, what is the parent function of g of x? X, so it's what? Linear. Okay, so do we have any domain restrictions? Remember, x values for linear functions. Do we have any domain restrictions? No. Okay, so to start off with, you know that your line or your linear function has no restrictions on its domain, so we're good with that. So it would be all x values. What about your f of x? The 2x squared minus x plus 4. What is its parent? Quadratic. Okay, so does a quadratic, which we graph as a what? Parabola. Does it have any domain restrictions? No, because if we visually look at that, so let's just take a coordinate plane. So if we have a parabola and it's going to infinity, what happens as it goes to infinity? Does it pick up all those x values? Yes. Yeah. There are restrictions on the range, but restrictions on the domain, no. So we started with no restrictions on either of these. What did we end up with? What's the parent of what we ended up with? Quadratic. So again, our composite is a quadratic. So are there any domain restrictions on your quadratic? No, again, not. So we would say that the domain would be all reals. Okay. Let's look at the g of x equal to 2 over x plus 1. Where is this one going to have an asymptote? Go to g of x. Where is that one not going to exist? What value of x is going to make this undefined? -1, right? That's where your asymptote is going to be. So x cannot be equal to -1, right? Because x plus 1, that transformation was what? We took it and we shifted it to the left 1. Now the asymptote is sitting at that -1. Try to relate this back to your transformations so that it makes sense to you. Okay, what about f of x? What transformation happened here? Plus 5, right? We moved this thing to the right 5. Therefore, our asymptote now is sitting at x equals 5. Therefore, that is a domain restriction. Does that make sense? Okay, so whenever you have your rationals, this is where those domain restrictions come in, and you have to pay attention to them. All right, so now what we need to do, since we are going to put the g of x into the f of x, we need to figure out where g of x equals this restriction. Okay, so we need to figure out where g of x equals 5 because we have to take that value out as well. Okay, so we'll come down here, our g of x, which is the 2 over x plus 1. We need to figure out when this thing equals that f of x restriction of 5. So we need to figure that out because that also will not exist. That will not exist as well. So if I want to solve this, 2 over x plus 1 equal to 5, I need to solve that for x. What's the first thing I need to do? Well, first of all, where is your x right now? In the denominator. How are you going to get him out of there? By what? Multiply by x? The whole thing, right? Multiply by the x plus 1, right? Remember, these guys are stuck together. Can't separate them. So you need to get that x out of there, so you're going to multiply by the x plus 1 to get it out. All right? So those would cancel. You're left with 2 over here. Over here, you're equal to a 5x plus 5. Okay, finish solving that for x. What are you going to do? Subtract 5. So that would leave you with a negative 3 equal to 5x. And then you're going to do what? Divide it by 5. So we get that x equals a negative 3/5. Therefore, that becomes a restriction, right? Because we cannot, your f of x cannot have this value of 5. Therefore, neither can your g of x. So our final domain restrictions x cannot be the original value up here for g of x. It cannot be that negative 1. And it can also not be what we just found as the negative 3/5. And there's your domain. Okay. We're including it here as the actual composition, as the composition itself.
Is it because it's of G?
Yes, because it's the composition. So we're bringing the composition into this. Yes.
So the one inside is the
So the one, yes, because that can't happen, right? And so we can't put that in when we go to actually compose it, do the composition. Okay, so let's take a look at the first one here. So you have 3 over x minus 1. You have to exclude the 1, right? 1 minus 1 would be 0. And over here you have to exclude what? 0, because you can't have 2 over 0, right? So now what's going to happen? Remember what you're doing, right? You're doing this right here. You're going to take that 2x, and where are you going to put it? You're going to put it there for the x, right? So that 2 over x cannot equal 1, right? Because if it equals 1, what's going to happen to this guy right here? He'll be undefined. So to figure that out, you just take that 2 over x, set it equal to that 0, and find out exactly where that's not going to exist, right? So how would we solve that? We would multiply both sides by the x to get him out of that denominator, and we would get 2 equals x. So therefore, that would be a domain restriction, right? Because what's going to happen if you put 2 over 2? What's that going to equal? 1, which has already what? Been excluded, right? So your domain restriction then would be x such that x cannot equal the 2 that we found here and the original 0, our original g of x. Does that make sense?
Yes.
Okay. Dulce?
I get that, but what I don't understand.
Okay, so our second one here, the x cannot equal negative 3, and over here x cannot equal, again, 0, right? So we are going to compose this. So again, essentially that negative 2 over x is going to get put in over here. So we cannot let that equal negative 3, so we're going to find where that actually happens. So negative 2 over x equal to that restriction of negative 3. So we're going to do the same thing. We're going to multiply both sides by x, because those will cancel. So we get a negative 2 equal to a negative 3x, and then what do we do? Then we're going to divide that negative 3 out of there, and actually that's going to bring us back a what? It's going to give us a positive 2/3. So the domain for this one, x such that x cannot be the positive 2/3, because that would make your g go to that negative 3, which doesn't exist. We can't have it. And it cannot be the, I'm out of room here, and it cannot be that original 0. Okay? Any questions on that? Does that make sense or not? Okay.